All right, our next video, we're going to talk about piecewise functions, and we're not going to do too terribly much with piecewise functions, but we're really just going to evaluate them, right? But a piecewise function is kind of like what it says, right? We have different pieces of functions pushed together to make one. So here's an example of a piecewise graph, right? So as you can see, it's a function. It passes my vertical line test, and we'll talk about that in a second. But I have one line here, one line here, and one line here. So I have three different lines put together to make one graph, right? Now remember, a function means that you have no repeating x values, and it passes your vertical line test. So it's pretty easy for the most part, except for where my lines end, right? And then we got these weird open and closed circles. So if you remember, if you think about your number line, right, when we go talk about graphing on a number line, right? If I wanted to include this number, right, I would use a closed circle, right? That's like the or equal to when we have inequalities. And then maybe I wanted to shade that way. But this means or equal to. And then if I didn't want that number, if it was just greater than, I would use an open dot and shade, right? So the closed dot is or equal to, the open dot is not or equal to, right? So that means here I have a point, but here I don't. It's like a hole, right? Because I'm going to get super, super, super close to this one point, but I don't actually include that point in this line, right? And the same thing here. I don't have a value there. It's up here, right? So it does still pass my vertical line test because I only have one value there, one value there. Okay, to evaluate using a graph, it's going to give you something like f of a number. This number is the x value, and I'm looking for the y value, right? So it's like an r. But all of these are going to be my y values. So if I'm looking for f of -5, I'm going to go to -5, right? And I'm looking here. This is a point that I'm looking for. So I want that y value. So this point right here is -5, right? And it looks like we're up at 2. So that means f of -5 equals 2. Right, then I'm going to do it again for -3. So I'm going to come to -3. Now this was a tricky one because I have a closed circle and an open circle, right, at -3. I want the closed circle. I want where I have a value. So that's going to be right here. So here's the next one. So this one looks like I'm at -3, 2. Right, so that means this one also equals 2. Okay, and then f of 1, right, looks like it's right there. That looks like a 1. That's my point 1, 1. So f of 1 equals 1, right? F of 3, right? Another tough one. I go to 3 and I've got 2 dots. I want the closed dot. So this looks like I'm at 3, 3. So f of 3 equals 3. And then f of 4, looks like I am down here. So it looks like I'm at 4, -5. So f of 4 equals -5. All right, the other way that we're going to evaluate is using the equation. Now the equation looks funky. I got this weird curly bracket here, and I could have 2 equations. I could have 7 equations, right? It's just all the different pieces put together, right? You're always going to have an equation with an inequality. The inequality is telling you where you have that part of your piecewise, right? So like up here, I switched at -3 and +3. Here, I'm switching at -3 and +3 because I have this equation for everything left of -3. I have this equation for the in-between, and then this one for the right side of 3, right? So this is just telling you where you're using your graph. To evaluate, you have to pick which one of these, based on the domain, which one of these equations we're going to plug in for x. Right, so up here I've got f of -5. So I'm plugging in -5 for x, but I'm only going to plug it in one time, okay, because it's a function, so I don't have any repeating x values. I have to pick one of these equations, and I do that based on where -5 fits. So my options are less than or equal to -3, right, bigger than -3, but less than or equal to 3, or bigger than 3. All right, so -5 is less than -3. So for this one, I'm going to use the top equation, right, because that's where -5 fits. So that means I'm going to do 2 times -5 plus 1. I'm just plugging in x. Well, 2 times -5 is -10 plus 1, -9. So f of -5 equals -9. -3, right? -3 is a tough one because it's on there twice. This is like up here where I had an open and a closed circle, right? So you have to pick which one we're going to use. Because I want to equal -3, I have to choose the one that's got the or equal to. So that's also going to be the top because I'm less than or equal to. So once I decide which one I'm going to use, I just plug it in for x. So I have 2 times -3 plus 1. 2 times -3 is -6 plus 1, -5. All right. Now this is different. It's the same numbers here and the same changing spots, but this is just a random one. This is not the graph that's up here. All right. Then we have f of 1. So I have to pick where 1 is. Well, 1 is not less than -3. All right. It's not more than 3, but it is in the middle. It's between -3 and 3. Okay, so we're going to use the middle. All right. Then if I'm going to use the middle, I'm going to plug it into that -x minus 2. So I've got -1 minus 2. And then we've got, that's just a -1. -1 minus 2, -3. So f of 1 equals -3. All right, then I'm going to do it again with 3. All right, but you got to be careful. 3's up here twice, so I got to find the or equal to. Well, the or equal to's with the middle. So I'm going to use that middle equation again. All right, and the middle equation is -x minus 2, so that's -3 minus 2, right? -3 is just -3. -3 minus 2 is -5. And for our last one, I'm looking for f of 4, and f of 4 would go in the bottom because 4 is bigger than 3. And the bottom one looks a little weird. The bottom one is just 4, right? That's like saying y equals 4 or f of x equals 4, right? And that means that it's a horizontal line. Right? If it's just a number, it's a horizontal line. That's going to look like this one up here where it just stays the same, right? And that just means that no matter where you go, your y value stays at that number. So here, anything that would make me choose this bottom equation because it's, just a number means that my answer is going to be just that number, right? Just like up here, anyone like these two where I was on that horizontal line, both of them were just 2 because that's where my horizontal line was. So anytime you have just a number, if your x value falls in line with that number, your answer is just going to be the number.